this first law of thermodynamics. First law of thermodynamics. So to define this first law, we have to know some basics in physics. First one is you have to know what is law of conservation of energy. Law of conservation of energy. Conservation of energy. So first one is you have to know what is this law of conservation of energy. And second is you have to know what is internal energy. Internal energy. Okay. And third one is you have to know what is this cycle and process. Cycle and process of the system you have to know. Next one is you have to know about the change of state or state you have to know. If you know all this, which one basics, you can define the first law of thermodynamics, right? So here the first law of thermodynamics is defined for the cycle and for the process here, right? So two definitions are there here for first law of thermodynamics, right? So actually two laws are there here. The first one is here, this one. First law is defined like this: delta Q equal to du plus delta W. Right? This is the first statement of the first law of thermodynamics. And this one is cyclic integral of this one, Q equal to delta Q can write down equal to delta W. This is our second statement here, right? So here we have three parameters here. One is Q, next is U, next is W. So Q, W and U. So these are the three parameters which we are seeing in this first law of thermodynamics. So you know what is Q? Q is heat, W is work, U is internal energy, right? Now why I am writing here delta for Q and writing delta for W, and for U I am not writing delta, here I am writing D. So why the different notations are there means it depends on which one point and path functions here, right? So what is this point and path functions? Already I told we have to know the basics regarding those one. First I will explain this, what is point and path functions here. Suppose if a system is changing from state 1 to state 2, right? So here these are known as point here, state 1 to state 2. Point, for a point we are defining, because at this one we will say the pressure is so much P1 and temperature is so much T1 and so on. Here at state 2 also pressure may decrease or temperature may increase and so on depending on the application part. So we will define this as P2, T2 and so on. Okay. So here these are point functions. We can say pressure, temperature are known as point function because at the points we are defining. So actually this is the path. Path may be in any form. Suppose I am taking this as a straight line light curve form. So if you take this as path here, so here for this path we will define this Q and W. Q and W are path functions. So it depends on the path here. Whereas pressure temperature does not depend on the path. Whereas Q and W depends on the path. So these are known as path functions. So in physics we will write like this. For point functions we will write P1, T1 and so on. P2, T2 and so on. Right? For Q we will write like this. Q1, 2 and this is W, 1, 2 and so on. Because this is a path 1, 2. Q depends on this path, W depends on this path. So don't write Q1, Q2 like this. Don't write like this. This is not Q2 minus Q1. This Q12 is path, depends on the path. So in physics, for point functions, we will use the notation D. For path functions, we'll use this notation. This for path function notation, this for point function, right? So in first law of thermodynamics, that's why I wrote the statement like this: delta Q equal to du plus delta W. Now you follow this notation. This is a path function, this path function, this point function. Internal energy is point function. So this is heat, this one is internal energy, this one is work. Okay. Right. Next is you have to know this which one process and cycle, right? So what is a process? Process is whatever the which one the graph which you took like this. This is known as process. 1, 2 is known as process. What is cycle? If starting and ending point is same. Starting point is 1, again reach the ending point. This is known as cycle, right? So for the process, you are defining first law of thermodynamics like this: delta Q equal to du plus delta W. Okay. For the cycle, you are defining like cyclic integral of delta Q equal to cyclic integral of delta W. Right. So these are actually two statements in first law of thermodynamics. Okay. Now we got what is point function, path function, what is process, and what is cycle, right? Next we have to know what is law of conservation of energy. So you know this law of conservation of energy. Law of conservation of energy. Energy cannot be created. Energy cannot be created, okay, nor destroyed. This is a famous statement, everyone knows. Energy cannot be created nor destroyed, okay, not destroyed nor destroyed, but converted in another form. Okay, so this is our which one law of conservation of energy. Energy cannot be created means, suppose if you take the which one sun energy, that is by nature we are getting that energy. We didn't create that energy, no. Sun energy, and wind energy, and so on. Sun energy we created, no, that is by nature, that energy is there. Wind energy we didn't create, that energy is there, right? So energy cannot be created, not destroyed. Can we destroy the sun energy? Can we destroy this wind energy? No. These energies can be converted from one form to another. That is our law of conservation of energy. Suppose if 10 joules of energy is there, here 3 and which one 7, energy converted from 10 joules of energy to other form of energy, 3 joules and 7 joules. Conversion. Total energy is constant. 3 plus 7 equal 10. That is another form of a law of conservation of energy. Energy cannot be created, not destroyed, but can be converted to another form, and total energy is constant. 10 joules, 3 plus 7, 10. Again here 10. Again converted this 3 and 7 to 10. So this is known as law of conservation of energy. So why this law of conservation of energy is important in our first law of thermodynamics is, here you are seeing the statement delta Q equal to this one you are writing du plus delta W. Sorry. This one is delta Q equal to du plus this statement you are writing. Okay. So here this is one form of energy, heat energy. This one is heat energy. Okay. This heat energy you are converting to internal energy plus work energy. So this is nothing but your law of conservation of energy. So your first law of thermodynamics is nothing but law of conservation of energy only. One form of energy converted to another form. So previous I told you 10 joules of energy are converting, suppose 6 and 4 here. Means 10 joules of it you are converting to 6 part of internal energy and 4 part of work energy. But total energy is constant 10. 6 plus 4 equal 10. That is the law of conservation of energy. So your first law of thermodynamics, another form is nothing but law of conservation of energy only. You are converting one form to another form. That is known as law of conservation of energy. And another statement, this is for this statement is for which function, path or point function. This is not point or path. This is for system or which one, cycle, process or cycle here. So this one is for process, not for cycle. For cycle, this du will not be there. Here also you are converting one form to another form. This is for cycle. Second statement of your first law is delta Q and delta W. So you are converting total heat energy to total work. Total work. So that is 10 equal to 10. So conversion of one form to another form is okay by law of conservation of energy. You can convert, but you can't create or not destroy. But total energy should be same. 10 joules equal 10 joules. So your both laws for the process or for the cycle, your law, it is nothing but the law of conservation of energy only. So your first law of thermodynamics, you can say this is nothing but law of conservation of energy. Law of conservation of energy. Okay. So both are same only. Converting one form of energy to another form. Total energy is constant. That is your first law. Now, in thermodynamics, now I am taking a system here. This is a system. Already defined what is system. Here you are supplying some heat here. So heat energy you are supplying to the system. So these are gases. So here the temperature will increase. Okay, because of this heat. So whenever a temperature increases, there is energy here. What is that energy called as? Inside the system energy is there. So that is known as internal energy. Because of the heat, energy is there increased. That energy is known as internal. Why internal? Because it is in the system. So that is known as internal energy. Internal energy. Okay. This is known as internal energy. Notation is U. So this U came because of supplying heat to the system. So that is internal energy. And one more thing is, you can convert this Q to U, one form to another form, because of law of conservation of energy. You are converting Q to U, that is okay, conversion from one form to another form. And one more thing is, you can do some work here. If you keep a piston like this, right, some part of the energy will move this piston upwards, like this. Means work is done by the system here, because there is a increase in the volume like this. So work is done. So U plus W. So Q you are supplying, there is an increase in internal energy and work is done on the system. That's why Q equal U plus W. Right? And one more thing is, here only kinetic energy will be there. Why kinetic energy? If you see the which one change of state here, like this is which one ice point, this water point, this vapor condition, right? So whenever change of state is there, here you can see whenever kinetic energy is there, means between these particles, whatever the which one energy, it will give to another particle here, right? That is a kinetic energy, because it will move with some velocity. But whenever particle is storing energy like this, it is nothing but potential energy. So because of this potential, there is a change of state from ice to water, water to vapor, because of potential energy. But after vapor, there is no state here. So here, these are the which one state which you are taking is the gaseous condition here. So there is no state here. So that's why there is no PE. PE means there should be a change of state here. But here there is no change of state. Already this is gaseous condition. So no change of state means only Ke will be there here, no Pe. Right? Now, overall summary of this first law of thermodynamics is two statements are there, delta Q equal to delta W plus du, and cyclic integral of delta Q equal to cyclic integral of delta W. So here for a cycle already I told, for a cycle starting and ending points are same, this is 1, 2, right? So here you are reaching this 1 means here there is no change here, internal energy will not be there, again reaching the same point, so that's why this value is 0. So this one, so we have to take all the Q and all the work here, Q and work, because it depends on the path. If you sum up this Q, cyclic integral means you have to add all the Q values and all the work values, both values should be equal according to the law of conservation of energy, one form to another form. Okay, so this is regarding your first law of thermodynamics. Thank you.